Energy from coal? That's right. Remember in the last podcast, we learned about how you make electricity. But today we want to focus in on coal. Now, coal is very important because coal is the most common way that we make electricity. So we're going to learn some more about coal and some very interesting things about coal. So let's talk about coal. First of all, what is the ultimate source of energy for the world? What can we where can we get our energy? Ultimately, the vast majority of our energy comes from solar radiation. So the energy comes from the sun and shines on the earth. Okay? You also could get some energy from the heat from the earth's interior. Okay? Or the decay of radioactive materials in the earth. These are kind of related. The heat from the earth's interior comes from the decay of radioactive materials in the earth. And there's also energy in the tides. In fact, there's interesting devices now being designed and made where we can use the energy of the tides, which is gravitational energy, and convert that into electricity. Typically, our goal almost always is to convert things to electricity, because electricity is the most useful of all energies in our modern society. Okay, so coal is actually solar energy. Huh? Well, you see, right? Because coal is dead things. That's right, dead things. Dead. That have decayed and turned into rocks. Coal. So basically, coal was once a plant, a tree or a leaf or of some kind of variety of a living organism. Most likely it was a plant. Very unlikely that there were animals. It was not like it was people and whatever. So coal is essentially a plant that's decayed. So let's talk about this. How does this all work? Well, in the photosynthetic process, if you're in biology, you'll understand this a lot better than probably even me. All right, the process by which plants use solar energy together with carbon dioxide and nutrients to synthesize plant tissues. What that essentially means is that there's carbon dioxide in the air. You know that. That's just out in the air. And it reacts with water in the air. This is actually happening inside of a plant. It's actually happening in the chloroplast part of the plant. Sunlight goes there and some other nutrients, and it turns into organic compounds. These organic compounds make up a leaf. See my leaf? So it makes up a leaf or whatever it happens to make up. And then that substance then can sometimes be turned into coal. All right, so let's talk about how coal is formed, or the formation of coal. Basically, some plant matter is buried. Now, first of all, it's very important that the plant matter gets buried. It cannot just stay on the ground, because if it just decays on the top of the ground, it will oxidize and it will not, I repeat, it will not turn into coal. But it must not be exposed to oxygen. It has to be away from oxygen. That's why if it decays on the top of the ground, like most things do, that it won't happen. So stage one is if you get a place, typically this happens in swamps, is the plant matter gets buried underwater, and then it's not exposed to the water. So a porous deposit, this is what peat is, of partially decomposed plant material at or near or not far below the Earth's surface. So then we make this substance called peat. We can find the plant bearing preserved in anoxic places. Now, anoxic, that's a funny word. Anoxic, that means without oxygen. Remember this? Okay. Then it gets buried by sediment. So now you've got these plants, right? You got my leaf. It gets buried by lots of dirt, sediment of some variety. And then you take time, pressure, and heat, and it, well, turns into coal. So in this process, I didn't get the research on there. It takes many, many years, thousands, maybe even millions. I don't know, a long time. So here's a good picture of how this looks. This might be the best thing to copy down to understand this. Here we have a swamp on the left, and the swamp produces peat. All right, here's our peat. And then if you wait and you get heat and pressure and time, it first turns into lignite and then turns into coal. So it's not very difficult, is it? Where do we find coal? This is kind of cool. I was doing some research. I thought this is really cool. Well, first of all, you find it with other sedimentary rocks. But what varieties? This right here is the Denver area. Here's Castle Rock. Some of you know where Castle Rock, Colorado is. And this is a cross-section near Castle Rock of the different geologic types of rocks underneath. And so geologists, they look for certain kinds of rocks. And this is different K, P. Remember we talked about this from the geologic map. And they look for these cross-sections. And when they find these cross-sections, they look for areas where it's going to likely be that coal would be found. some types of rocks they find coal in, some they don't. And so it'd be silly to look where there's unlikely to find coal. So they love to find these cross sections. So if you look right here, you can see some sort of blackish lines. And when they figure out this cross section, then that is an area where they can find coal. So there's some coal here in these Rocky Mountains, and we dig it up and such. All right. Now, how do they actually get those cross sections? How in the world do they know that this far down there's this D1 sequence? Okay, they use a technique called reflection seismology. This isn't the only technique, but it's one of the more common ones. It's a method of exploration, geophysics, Earth, physics of the Earth, okay, that uses the principles of seismology to estimate the properties of the Earth's subsurface from reflected seismic waves. What in the world did Mr. Bergmann just say? Basically what they do is they create small mini earthquakes. So here's the ground, and they have somebody who tap, 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 and then they have all these microphones placed around, and they kind of make mini earthquakes. Sometimes they have machines that are huge that are tapping the ground, and then they kind of make mini earthquakes. Not earthquakes that are going to cause any damage to the world or trigger another earthquake, but that they can help them figure out the cross section. I think the best way to look at this is this, oops, what did I do here, is to look at this little video clip I found on YouTube that's pretty cool, that helps us understand how reflection seismology works. So let's take a gander at this.
One of the steps involved is a technologically intensive technique that has been continuously developing and improving over the past 80 years, a geophysical imaging technique called reflection seismic surveying. Seismic survey data is collected by sending sound waves into the Earth from source points on the surface. These sound waves reflect off the layers of rock and are recorded back on the surface by microphone-like instruments called geophones or hydrophones. The recorded data is then processed to create an image of those rock layers, the same process used for the medical imaging procedure of ultrasound. Using this type of geophysical data, geologists and geophysicists can much more accurately locate and monitor deposits of oil and natural gas that lie beneath the Earth's surface.
Very cool. Those guys know what they're doing, don't they? Wow, some smart people. And there's math involved. Math and science. Oh, yeah, of course there is. Hey, last few things I want to talk about here. Where do we find the carbon, or where do we find the coal? Well, here's the different varieties of coal. We don't really go into the details of this. It's not really important. There's lignite coal. It's got a 25 to 35% carbon content. And so the BTUs, we talked about it in the first podcast, the BTUs is what's called the British thermal unit. So if a pound of lignite, we'll have 4,000 to 8,300 BTUs in it. Then there's the subbituminous. We get a little higher percentage of carbon, and we can see more BTUs per pound. There's the bituminous, a little higher. We get a lot more energy. Wow, 15,000 BTUs per pound. A lot of energy in this. And the best coal there is anthracite, 86 to 89% carbon, and about 15,000 BTUs per pound. So if you're going to burn coal, of course the coal you want to burn is the coal with the highest amount of energy. Now that's not completely true. You're also looking for what we're calling clean coal, because some coal has other impurities that are bad for the environment, because when you burn this coal, that turns the turbine, or it turns the magnet around the wire, which turns the turbine, which produces the electricity, right? That causes gases to be given off. So I got a smokestack here, right? And I'm burning, and these gases go up, and some of the gases are dangerous. And so some types of coal, depends on where you mine it and whatnot, is good, and some of it is, well, not so good for the environment. So there's ways to clean it up and scrub it out, as they say, but that's another issue. So here is the U.S. coal deposits, okay, depending on type. So the yellow is the lignite. Now that's kind of the worst coal. The yellow is the worst coal, and you can kind of see, and if you really know your stuff down here, there's not a lot of coal mining that's really going on here. It's there, but it's not really being mined. The next level is the subbituminous, that's sort of the teal colors. You can see some of that. Here's Colorado, right? And some of this is in Wyoming and such, okay? And then some of the subbituminous is actually up here, a little deeper green. And this right here is very heavily mined. And in fact, if you see the trains coming from Wyoming down to Colorado, that is, excuse me, the coal that we're burning. The good news, even though it doesn't have as much energy in it, this is very clean coal. It has less of those nasty chemicals in them. All right, and then the medium and the high bituminous, you can see you get a better coal, and this is kind of a big region right here where you can see this, and that's in West Virginia. In fact, sadly, I don't know if you guys have been following the news. If you're watching this now, 25 miners just in the last few days in the West Virginia mines, they died in a coal mining accident. So it was a bad deal, obviously. So yeah. So this is where we find the coal in the world, or in the United States. So that's the end of this podcast. Relatively short one after that long one. Okay, we'll talk to you later. Bye.